Hello students, in earlier videos we have seen what is potentiometer and what are their applications. In today's video we are going to study galvanometer and what is their applications. A galvanometer is a device which is used to detect very weak electric currents in a circuit. Here you can see the diagram of galvanometer or the internal structure of the galvanometer. Here is the scale, you can see the marking, it is 0 at the center and then 10, 20, 30 on both sides of the scale. So when there is no current flowing through the circuit, this arrow, this needle shows the 0 marking. Then this is horseshoe magnet, and in this magnet the coil is placed. This is in rectangular shape and it is wounded on the iron core. So this iron core helps us to increase the magnetic flux. When there is current flowing through this coil deflects and this arrow attached to this changes its direction and shows us the readings, maybe 10, 20, 30 like this. Why this happens? Because when the current is flowing through wire in the magnetic field, the force acts on it and it deflects, that is mechanical force acts on it, and so we will get some deflections. This is used to detect very small currents, and we will see how we can use the galvanometer as an ammeter as well as a voltmeter. So we know what is the ammeter. Ammeter is the device which measures the current through the circuit. So to measure the current, what we should have? We should have minimum resistance of the circuit. Suppose here is some circuit moving around this and I have to find out the current I flowing through this. Okay, so what should I do? Always remember that we attach the ammeter in series. So whatever construction I have to do with galvanometer, I have to attach this with in series. Suppose there is resistance R. So suppose I don't know whether I have to do something in parallel with this galvanometer or in series. We will discuss this. Okay, suppose here is current flowing. So to find out how we have to convert this galvanometer into ammeter, we need to check some properties of ammeter or what we require to make it as an ammeter. The first property is that we should have higher current capacity, that is maximum current should be flown through the ammeter so that we can measure it accurately. Suppose there is current I is flowing through circuit and I can measure only 10% of the current, then there is no use of ammeter. So maximum current should be measured with the help of ammeter. How can we do that? So the resistance of the ammeter must be as low as possible and it should be approximately equal to 0. Ideally we cannot have 0 value but close to 0, very less. Suppose this R is supposed 100 ohm, then we can have resistance very low, that is we can have less than 1 ohm, the resistance of the total ammeter, not just galvanometer. One more thing we should remember, that the galvanometer should be out of damage. So it should not get damaged due to high current. Suppose this is very high current, then galvanometer is very sensitive device. It can damage. So what we have to do is we have to pass maximum current through ammeter but minimum current through galvanometer. So how can we do that? We can do this by connecting the resistance parallel along with the galvanometer. So suppose this is S. Why this is called as S instead of R? So this is called shunt resistance. This is called shunt resistance. So it is denoted by S and the galvanometer has resistance G. So what will happen? This shunt resistance, or we can say it is in parallel. So this parallel resistance is very low. So it is less than 1 ohm. So that what happens when we attach two resistance in parallel, the total resistance or the resultant resistance of the circuit or the equivalent resistance of the circuit becomes less than the lowest value of the resistance. So the resistance of, suppose this is value is zero point 0.5 ohm, then the total resistance of this circuit becomes very less. Suppose here is point A and here is point B. If the resistance between these 2 points is very low, then whatever the current is flowing through this, all the current will flow through this. Now what will happen, as this is very small resistance, current will pass through the path where the resistance is very low. So maximum current is going to flow from this side, from A to shunt to B, and very low portion of the current is passing through A, G and B, that is through the galvanometer. So how to find out? Let's say total current I is flowing through this circuit, and then here it will get divided. So let's say the current I is equal to, it will get divided. How? Let's say the current flowing through the galvanometer is equal to Ig, I, and then subscript G, plus the current flowing through the shunt resistance, we will call it as Is. So this is our first equation. Using this we can solve for the current. Then we can see that here the galvanometer and shunt are in parallel. So we know in parallel the voltage is equal between these 2 points A and B. Voltage must be same. So we can write voltage is current into resistance using Ohm's law. So we can get I into G, that is the current flowing through the galvanometer, into capital G, that is the resistance of that galvanometer, must be equal to Is, that is the current flowing through the shunt resistance, into the resistance of shunt is S. Now if we put, or using this equation, we can find out what is the value of Is, right? So Is can be written as I minus Ig. So Ig becomes here, Ig goes to left and becomes negative. So I minus Ig is equal to Is. So if we put this value here, then we can find out the value of shunt resistance. So if we put this is equal to I minus Ig into S, that is shunt resistance. So if I have to find out the shunt, what will I do? I will divide this bracketed term I minus Ig to this quantity. So I will get the shunt resistance S is equal to Ig, capital G, divided by I minus Ig. So if we decide what should be the current flowing through the galvanometer, maybe 5% of total current, 2% of the total current, then we can find out, we will know what is I approximately, and then we can find out the shunt resistance. Suppose that we already know the value of G, that is galvanometer. So using this equation we can find out what is the parallel resistance should be attached with the galvanometer to convert this into ammeter. So we are having these two equations. This is for using Kirchhoff's current law. I is equal to Ig plus Is, that is this is the current through galvanometer, and I is the current through shunt resistance. There is another equation from voltage law, that is G Ig is equal to SIS. So this is current through galvanometer, current through shunt resistance. G is the resistance of the galvanometer and S is the value of shunt resistance. So using this first equation, we can put Ig is equal to, we can write Ig is equal to I minus Is. So if I put here I minus Is, we will get Gi minus G into Is, that will be equal to SIS. So I will take this term to RHS and we will take common Is. So it will become Gi is equal to Is into in bracket S plus G or G plus S. So if I have to find out the ratio of Is to I, how we can write it? So Is divided by I, that will be equal to G divided by S plus G. So this will be the ratio of the current through shunt resistance and the current total current. Similarly, we can find out the ratio of currents of Ig divided by I. In above calculation, we substituted Ig is equal to I minus Is. So instead of putting at Ig, we will put I minus Ig in place of Is, and we will solve for Ig, and then we will divide by I, and this will become S divided by S plus G. So the denominator of both quantities is same, and if you add these two terms, Is divided by I and Ig divided by I, you will get equal to 1. So this is the construction of ammeter. Now we will see how we can convert the galvanometer into voltmeter. So first of all, we should know what is voltmeter. Voltmeter is a device which measures the voltage or potential difference between 2 points. And voltmeter will always be connected in parallel in the circuit. Suppose here is some circuit. I will not draw all the part. So the current I is flowing through this. Here is some current R. So we have to attach the voltmeter in parallel. So our voltmeter will be in these 2 points. So the galvanometer will be here, and we don't know whether the galvanometer will be in parallel with the circuit or in the series with another resistance. So we have to find out. Suppose I will draw here a galvanometer. So I don't know whether the resistance we have to attach in parallel or in series. So we will find out how we can do that. So first of all, as we have seen in case of ammeter, our current capacity should be increased. In this case, our voltage capacity should be increased. So this is the first point, voltage capacity. Then the second point is the resistance should be as high as possible. So resistance should be high. Ideally, the resistance of voltmeter is infinite, because what the voltmeter does is it do not pass any current, it just measures the potential difference so that the accurate voltage can be measured, and that's why the resistance should be very high, or ideally we call it as infinite resistance. And the third point is that the galvanometer should not be damaged due to high current. As we are passing very low current, there will be no damage to voltmeter. But how we can apply the maximum resistance? So in previous case we have studied that we have to reduce the resistance, so we attach the small resistance in parallel, but here we have to increase the resistance. So what will we do? We will attach very high resistance in series. Let's say this is X. So we don't know what is the X, what is the value of X, but we have to find it out. So how we can find out? Similar to previous case, we will find out Kirchhoff's law, and using that equations we can find out the X. Now suppose current I is flowing through this, but only small part of that current is flowing through the galvanometer. So we will call this as Ig. Consider this loop. We are going to consider the voltage law. The voltage in between this and this point is exactly same as through this path or through this path. So this is I into R, that is equal to V. That will be equal to the current passing through galvanometer is I into G, and the resistance of that galvanometer is capital G, plus this current is also passing through this resistance which we are attached in series. So the current will be the same. Current will be same in the series, and voltage will get added. So Ig into X. So this is the equation we are getting from Kirchhoff's law, and then if we rearrange this we can find out the value of x. So I will move this part to LHS, and then to V minus Ig we will divide by Ig. So we can get V minus Ig into G divided by Ig, and this is equal to x. So this is the unknown resistance which we have to add with galvanometer in series to make it as to work as voltmeter. So you can further simplify this. V divided by Ig minus, so Ig and Ig will get cancelled, so here it will be capital G only. So we can find out the value of x using this equation. So we will see now what is the difference between ammeter and voltmeter. So in the book you have given this in tabular form. The ammeter measures the current while voltmeter measures the potential difference or the voltage. Ammeter is always connected in series with the circuit, while the voltmeter is connected in parallel with the circuit. The ammeter is the MCG, that is moving coil galvanometer, with very low resistance. So ammeter ideally has the zero resistance or practically low resistance. Similarly, the voltmeter will have very high resistance or ideally infinite resistance. If we have smaller shunt, the greater will current measured. So we try to get very small shunt in case of ammeter, while in case of voltmeter we try to get very high resistance. Higher the resistance, higher the potential difference measured, and in ammeter smaller the shunt, greater the current will be measured. The effective resistance of the ammeter can be calculated using our regular addition of parallel circuit resistances. So this will become S into G divided by S plus G. And in case of voltmeter we will get, they are connected in series, so they will simply get added G plus capital X. So this is the difference between ammeter and voltmeter. Thank you.